In this video, we'll open a pressure switch, see how it works inside, adjust the set point, explain the NO and NC contacts, and test it live. Pressure switches are commonly used in industrial automation, pumps, compressors, HVAC systems, and safety circuits. They are simple devices, but they play a very important role because they convert pressure into an electrical on/off signal. Here you can see the pressure range of this switch, printed on the housing. This range tells us the minimum and maximum pressure where the switch can operate correctly. In a moment, I'll show you how to adjust it, but first, let's see the mechanical reaction. When I press the diaphragm, you can hear a clear clicking sound. That sound means the switch is tripping. The internal contacts are changing state. Now let's open the pressure switch and see what's inside. This black component here is the switching mechanism, and this small button is the plunger. When the pressure reaches or exceeds the set point, the diaphragm pushes this plunger and the switch trips. This adjustment nut here controls the set point. When we move it closer, the switch trips more easily at a lower pressure. When we move it further away, the switch needs higher pressure to trip. So, by adjusting this nut, we control at which pressure the switch will turn on. Now let's look at the electrical terminals. We have 3 terminals: common, normally open, and normally closed. Depending on the application, we choose the contact that fits our purpose. With the normally open contact, the circuit closes when the pressure reaches or exceeds the set point. With the normally closed contact, the circuit opens at the set point. This makes pressure switches very flexible for control and protection applications. Now let's see how the pressure switch works in real life. Here I have a hand pump, a pressure measuring device, the pressure switch, and a light bulb connected to the normally open terminal. The bulb gives us a clear visual indication of when the switch trips. I'll start pumping pressure manually. We can see the real pressure value on the gauge, and at the same time, we can see exactly when the bulb turns on. The switch trips at approximately 60 millibars, which means it's currently adjusted for a low pressure. Now I'll adjust the pressure switch for a higher set point. You may notice that the pressure on the gauge is slowly decreasing. That's because there is a small leak, and I apologize for that. Let's pump again. Now the switch trips at around 860 millibars. This clearly shows how changing the adjustment affects the tripping pressure. Pressure switches like this are widely used for pump protection, compressor control, pressure alarms, and safety interlocks. They are reliable, simple, and extremely important in industrial systems. That's it for this video. If you have any questions, write them in the comments. If this video was helpful, don't forget to like and subscribe. Thank you for watching, and see you in the next one.